All right, guys. Are there any questions over any of the assignments thus far? Question over any of the assignments thus far? All right. What we're looking at today is simplifying complex fractions. Now, what we define a complex fraction as is a fraction inside fractions. So the numerator and denominator of this fraction will have fractions. And we can't leave it that way. So we can't leave a fraction in a fraction. Let's face forward. So it'd be the same as saying 7/3 over 1/3. We can't leave this fraction in a fraction. Now, luckily, if we had 7/3 over 1/3, we can just plug that in a calculator and the calculator will do it for us. It'll simplify it for us and essentially say that 7/3 divided by 1/3 is 7, which isn't too bad. Or we could say, see here, 1/4 divided by 1/2 is a half. But for what we're doing here, we're going to have variables in top and bottom of the fraction. So we can't just plug it into a calculator. Now there's two methods to doing this. Method one is simplifying the numerator and denominator, the top and bottom of this fraction, into a single fraction, and then dividing from there. And then we have the second method. Now, for the first method, I'm going to suggest that y'all watch this one here and then follow along with method two. Because I have a feeling that I'm going to do method one, we'll do method one together, and then you're never going to touch method one again. You're not going to want to do it. Now, method one, what it states is that we have to turn the numerator and denominator, top and bottom of this fraction, into one fraction. The numerator is fine. It is already a single fraction. Now, the denominator we have 2. So we need to actually add these together to get them to be the same. For us to be able to add or subtract, we need the denominators to be the same. Yes. So for the one on the left, the 1 over x plus 4, we're going to need to multiply it by x over x to get the denominators to be the same. The one on the right, we're going to need to multiply top and bottom by x plus 4 over x plus 4 to get them to be the same. Riley, if you'll grab the door. Thank you. And if we do this multiplication, 1 times x is x. The denominator is now x times x plus 4. The other fraction. On the bottom of the fraction, we have x times x plus 4. The numerator we distribute. 2 times x is 2x. 2 times 4 is plus 8. Questions on this so far? So we're only doing this, the reason we're doing this with the bottom of the fraction is for us to be able to add these together. The numerator is going to stay 5 over x plus 4. Now the denominators we can add together because the denominators of the denominators are the same, which will give us x times x plus 4. The numerator, we're going to have x plus 2x plus 8. We're going to add those together. Now, at this point here, we can combine like terms. So our x, here, the x plus 2x are going to add together to give us 3x plus 8 over x times x plus 4. So this first whole process is to get it so that we have one fraction on top and bottom of this fraction. Now, realistically, fractions are just another way of saying that we have the top of the fraction divided by the bottom. Top of the fraction divided by the bottom of the fraction, which we don't really divide to fractions. To simplify, we can change it, keep the first one, change it from division to multiplication, and flip the second. And when we multiply these together, we get 5x times x plus 4 over x plus 4 times 3x plus 8. Well, x plus 4 and x plus 4 will cancel, leaving us with 5x over 3x plus 8. And that is the final answer, and that is one method for doing this. Now, method 2. Method 2 here. What would happen if we multiplied this numerator term by x plus 4? What would happen? Yes, because this x plus 4 and this x plus 4 would cancel out. What happens if I multiplied this one down here by x plus 4? Does the same thing. And this 2 over x, we would need to multiply it by x, yes? So we can use this least common denominator, which what we were doing to add or subtract, to simplify these out. So we're going to multiply the top of the fraction and bottom of the fraction by this least common denominator, which part of it is x plus 4. Now, how many times does x plus 4 appear in the entire fraction? Twice. In each of the individual fractions, how many does it appear? So how many times will I need to multiply it on top and bottom by everything? Once. Do we need anything else? We need the, because if I use this least common denominator to multiply the top and bottom of the fraction, it's going to make it easier to work with. Now, the reason we can do this is, well, what is x times x plus 4 over x times x plus 4 really? Anything divided by itself is. So really, we're just multiplying the whole thing by 1. Now, if we multiply the numerator, multiply this by the numerator, so this is all going to multiply by the 5. If we wrote it out, we'd have 5x times x plus 4 over x plus 4. Yes? Question? Now, we'll do the same thing with the denominator, the bottom of the fraction. So the x times x plus 4 will multiply with the 1, which give us x times x plus 4 over x plus 4. Because the nice thing with multiplying with 1, it's just the same as what we're multiplying it by. Plus, when we do the x times x plus 4, and we multiply with the 2, we get 2x times x plus 4 over x. Questions on how we got to this point here? Because what's 1 times x? 1x, or x. Yeah, since it's being multiplied with 1, we can just rewrite it as x times x plus 4. We don't need the 1 there. We can write it, but it's not going to be any different. Does that make sense? Now, looking at each one of these here, well, on top, the x plus 4 and x plus 4 will cancel. This one here, the x plus 4 and x plus 4 will cancel. Here, the x and x will cancel out. And what that leaves us with is 5x over x, because that's all that's left here, plus 2 times x plus 4. Questions on how we got to this point here? Now we do need to distribute and then simplify, because we can distribute the 2. 2 times x is 2x. 2 times 4 is plus 8. 2x plus x is? Now the denominators 3x and 8 don't have anything in common, so we can't factor anything out. We can't reduce it. That's as simplified as it gets. Now, as we can see here, method 1 still got us to the same answer, yes? A lot more steps. But method 2 is a lot easier and a lot faster to get there. Questions on this here? Are you ready for the next one? Yes. Do we want to solve this one by method 1 or method 2? Yep. And I will tell you, most every year I use the first method on the first problem that we do, and that's the last time we normally do it, because most everybody prefers the second method. So what would we need to multiply the top and bottom of this fraction by? X minus 2 and x. X minus 2 and x. Now the top of this fraction is we're going to multiply x and x minus 2 by the numerator. So this will be 6x times x minus 2 over x minus 2. And we know eventually the x minus 2 and x minus 2 will cancel each other out. Now if we do this with the denominator, we'll have x times x minus 2 times 1, which is just going to be x times x minus 2 over x minus 2. And again, the x minus 2 and x minus 2 will cancel out. Plus 3 times x minus 2 over x, and the x and x will cancel out. Let's see what that leaves us with. The numerator is going to be what? 6x. The denominator is going to be x plus 3 times x minus 2. Now we do need to simplify the denominator, so we need to do 3 times x, which is 3 times negative 2 is negative 6. On the page just a little bit. Combine like terms, x plus 3x is 4x minus 6. The numerator is a single term, so we can't factor do anything with it. Can we do anything with the 4x minus 6? Anything in common with 4 and 6? 2. Okay. If we're able to simplify them at all, we do need to simplify them, even if it's just factoring something out of the denominator's 2 terms. Because there is a slight chance that we do get something in common on top and bottom by doing that. Because here we have what? 6 over 2. Will those simplify? 3. So it would be, would prefer not doing that. We have 3x on top, yes? Because this would simplify with the 6, making it 3, and the 2 is now 1, which really just leaves us with 2x minus 3 on bottom. The 3x and 2x will not simplify with each other because of the minus 3 on bottom. 2x minus 3 is a single term. We can't just start crossing things out that way. So that is it. Questions on this here? Are you ready for the next one? So this one here is a little bit different. One, we don't have any variables on bottom of the fractions. We just have numbers, yes? Still works the exact same. We just need to see what number do we need to multiply each of these fractions by to get the denominators to cancel out, to simplify out. So we're trying to see what is the first number that we can turn 6, 3, 5, and 10 into that'll cause them to simplify. So we're looking for the first number that will go into all four, or all four will go into. Because with 6 and 3, the first number is all 6, yes? We can turn both 5 and 10 into 10, yes? So we're really looking to see what is the first number that we can turn both 10 and 6 into, which is 30. Because 30 is the first number we can divide 10, 6, 5, and 3 into. So what do we need to multiply top and bottom by? 30 over 3. Because 30 times x is 30x, and it's going to be over 6. Minus 30 times x is going to be 30x, but this time it's over 3. We'll do the same thing in the denominators. 30 times x is going to be 30x over 5. Minus 30 times 7. What's 3 times 7? Add a 0. Thirty divided by 6 is, and we have our x, minus 30 divided by 3 is x. 30 divided by 5 is 6x, minus dividing by 10 is nice, because it's just moving the decimal to the left. Now looking at this here, 5x minus 10x is negative 5x. Can we combine the 6x and 21? Is there a greatest common factor between 6x and 21? That we can factor out. 3 factored out of 6x is 3 factored out of 21 is 7. And 5 over 3 will reduce to what? 5 over 3. It doesn't reduce, right? That's the answer. Even though factoring it out didn't actually cause anything to simplify, we still need to factor it out. That's it. Any questions on any of this here? Hopefully, the next statement I make, y'all would agree with that these are probably harder. They looked harder than what they actually were. Yes. And hopefully that's starting to become more and more true about most of the stuff we covered, that it's easier than what we thought.
Yeah, until we get through that.
So, I'm going to do that one.
Do we want to look at this one here?
Nobody wants to yet.
So, which two fractions do we have? 2 over x and the 4 and 3 are a part of the whole fraction, but do they have a fraction in themselves? No. So the only ones we're looking at simplifying are the 2 over x and what do I need to multiply 2 over x by to get the denominator to cancel? X, because 2 over x times x would cause the denominator to simplify, yes? So we'll need to multiply the whole thing by x over x. Well, the bottom 2 over x, we need an x. We already have it, yes? Because since x only appears once in each of the fractions in the fraction, we only need it once. If one of these had said, we had said been x squared, we would have needed to multiply not by x, but x squared. Since we don't have x squared, we just have x. We're going to multiply top and bottom of this by x. So here, x times 2 over x is 2x over x. X times negative 4 is negative 4x. Same thing on bottom. We get 2x over x, and x times 3 is plus 3x. Here, x over x will cancel. Here, x over x will cancel, leaving us with 2 minus 4x over 2 plus 3x. Is there something uncommon in the top two terms? Well, they both have a greatest common factor of 2, yes? If we factor 2 out of 2, we have 1 minus 2x. Is there a greatest common factor on bottom? No, so it's 2 plus 3x, yes? Well, the 2 plus 3x is one term. They're stuck together with the plus. So is there any way I could simplify it with the 2 on top that we just factored out? No. So that's it. Questions on this here? I think we feel pretty comfortable with these here, yes? Yes. So, looking at the 4 denominators, what is one thing we know we'll need to multiply the top and bottom by? A minus 2. Yes. Because the a minus 2 will simplify with these 2 here. The a will simplify with those 2 there. And does that simplify everything out of the bottoms of the fractions? Yeah. Now at this point here, we can multiply. So we'll multiply the a times a minus 2 with 1, which would give us a times a minus 2 over a, minus a times a minus 2. We're going to multiply with the 3, which will give us 3a times a minus 2 over a minus 2. The denominator, a times a minus 2, we're going to multiply it with the 2, which will give us 2a times a minus 2 over a, plus 5 times a minus 2 is 5a times a minus 2 over a minus 2. Now let's see what will cancel. Here the a and a will cancel. And we have the a minus 2 and a minus 2. So everything left on top is a minus 2 minus 3a. The denominator here, the a and a will cancel, leaving us with 2 times a minus 2 plus. Here the a minus 2 and a minus 2 will cancel, leaving us with plus 5a. Now we don't necessarily need the parentheses on top. We can just say a minus 2 minus 3a, so we'll simplify that here in a minute. The denominator we'll need to multiply through by 2. 2 times a is 2a. 2 times negative 2 is negative 4 plus 5a. Questions on this here so far? Yes. Because 2 times negative 2. The numerator a minus 3a is negative 2a minus 2. The denominator 2a plus 5a is 7a minus 4. Now we can simplify this a little bit. Is there anything in common in the denominator, 7a and 4? No, so that's just going to be 7a minus 4. Is there something in common with negative 2a and negative 2? They both have a, yes, question.
How did you get the 2a on top? But the negative 2a?
Now, what we can factor out of the numerator, we can do one of two things. We can either factor the 2 out, or we can factor the negative 2 out. Doesn't really matter which. If we factor the negative 2 out, we're left with a plus 1. If we just factor the 2 out, we're left with negative a minus 1. Either one works. Either one's the correct answer. Now, the reason we would factor the negative 2 out is if one of the denominators had a factor of a plus 1, then we would need it to be able to cancel out. But here, since there's no like term on top and bottom, it really doesn't matter which one we choose. Any other questions on this here? We're going to look at one more, and this one here is going to be it. This is the last one we'll look at together. Yes and no. Because if we look at top and bottom, we only have one fraction in the numerator and denominator, yes? And the bottom of both of them is so we need to multiply the top and bottom by 2x plus 3. So here in the numerator, there's no fraction with it, so we don't have to worry about it. The 4 doesn't have a bottom or denominator with it. It isn't a fraction, but because there's not a fraction on top with those, we don't need to do anything with it. Because really the ones that we're focused on are this one right here and this one right here, because those are the only two fractions in the fraction that we need to simplify. And we can do that by multiplying top and bottom by 2x plus 3. Now we're going to multiply all three terms by it. Now we're not going to go on and just multiply everything out because there is a lot that we're multiplying here. So let's just write it out first. So the first one is going to be x times 2x plus 3 minus 4 times 2x plus 3. Then we have plus, because it only multiplies with the numerator, we have 9 times 2x plus 3 over 2x plus 3. And we know what the last one, 2x plus 3 and 2x plus 3 will cancel out, really just leaving us with plus 9. Now we'll do the same thing with the denominator. Multiply through. And the first one will have x times 2x plus 3. Plus, and we'll do 3 times 2x plus 3. Minus, yes. And exactly as you're saying, because we'll have plus 9 left over and minus 5, because those will just simplify down. Now for this one here, it's not too bad to have just gone on and write plus 9 and minus 5, because that's the only thing we have, and those will simplify nicely. Some of the ones, really all the ones we've done so far today, we could have just simplified it out as we multiplied in, and it wouldn't be too bad. When we start getting more than 1 or 2 or 3 terms, especially like 2 parentheses, if it had 2x plus 3 and 2x minus 3, it might be good to write some of those back out so we make sure what stays and what actually simplifies. Now at this point here, we just need to simplify. X times 2x is 2x squared. X times 3 is going to be plus 3x. Negative 4 times 2x is negative 8x. And negative 4 times 3 is negative 12. The denominator, same thing, we'll distribute the x. X times 2x is 2x squared. X times 3 is plus 3x. 3 times 2x is plus 6, and 3 times 3 is plus 9. So they would if they're being multiplied with the rest of it. Since they're still being all added, subtracted, we'll have to combine like terms. Now 2x squared is the only x squared term in the numerator. So we have 3x minus 8x is negative 5x. And lastly, negative 12 plus 9 is negative 3. The denominator, well, 2x squared is the only like term. But we have 3x plus 6x is plus 9x. 9 minus 5 is negative 4. Now the question is, will the numerator and denominator factor? Well, we can check, because our negative 5 squared minus 4ac, because our b squared minus 4ac will tell us if it does factor, because if we get a whole number, it will factor. Second square root, negative 5 squared minus 4 times 2 times, what was it? Negative 3. Because this is A, this is B, this is C.
Hold on. Where'd you get the negative 5 squared at?
So b squared minus 4ac. It's part of the quadratic formula.
Let me write that down.
Since the 3 is negative, our signs are opposite, positive and negative. Factors of 2x squared, well, we'll have x and x. 1 and 2, 2 and 1. I'm just going to throw the 2 in the first one, because we can check it. If we get the correct number but wrong sign, we can just flip the signs. And the only factors of 3 are 1 and 3. Now we can check this here. 2x times negative 3 is negative. 1 times x is plus x. 6x, negative 6x plus x is negative 5x. Is that what we wanted? Okay. Let's make sure. Well, what's 9 minus 5? It should be plus 4 instead of minus, because 9 is the bigger term. 9 minus 5 is plus 4. I think you'll probably have that. Yeah. Now, since the third term is positive, the signs are the same, and they match the sign of the middle term, which is plus. We have plus and plus. Factors of x squared are x, and the factors of 2 are 2 and 1. Our factors of 4 are 1 and 4 or 2 and 2, yes? Now, if we want something to cancel, we need it to be the same on top and bottom, yes? Is there any way to make one of the denominators be x minus 3? Well, yeah, 2x plus 1 and x plus 4. Well, for two things, 1, 3 is not a factor of 4, and 2, since they're both plus, there's no way to get x minus 3. So we're sticking with 1 and 4, because now we can have 2x plus 1 and 2x plus 1. Now we can still check it just to make sure. 2x times 4 is 1 times x is plus x, which gives us, so that is, cancel out, leaving us with 3 over, and that is the final answer. Some of these look worse than they are, and the rest of them are essentially the same way. Take it step by step. Unfortunately, for not the one after this, but the one after that, we can't just cross them out because the signs in the middle are opposite. Yep. So if you want to see that one, I do have it included in last hour's video. I did work through that one. Yeah.
How come you don't work out at college?
I don't know. I enjoy working here.